Welcome to the project demonstration of temperature based AC fan speed controlling system using triac and also monitoring the temperature and fan speed level on the things cloud platform through the Blynk app. So here we are going to control this fan speed controlling through the triac, that is BT136, and also we are going to detect the zero crossing using this zero crossing detector, and the whole system powered with the 230 volts. So from this cable we are going to provide the 230 volts input, and this transformer will step down the 230 volts AC to 12 volts AC, and that was input to this regulated power supply board. And on this we can see the 4 diodes are connected in a manner of bridge rectifier, so that we will get 12 volts pulsating DC. And from this capacitor the pulses will be removed in the pulsating DC, so we will get 12 volts pure DC voltage. And after this 7805 regulator we will get a 5 volts constant regulated power supply, and there was a main power source in power input to the PIC microcontroller. So here we are using PIC 16F73 microcontroller. So it start reading input from the LM35 which is connected at A0, and based on this temperature value we are going to control the fan speed through this BT136 triac which is connected at C0, and also the zero crossing detector connected at B0, and we are going to sending the temperature as well as fan speed levels to the Blynk app through this ESP8266 module which was connected at B0 B1, and LCD module at B2 to B7. So coming to the component wise board explanation. So here the triac board consists of diac, that is optically diac 1. So this diac will trigger the triac. So means we are going to trigger the diac and the diac will trigger the triac. So why? Because triac need AC signal to trigger by itself. That's why microcontroller can't provide AC signal as it's a DC electronic component. So now the diac will provide the AC signal output to triac whenever it get the DC signal from the microcontroller. And coming to this zero crossing detector, so here we are providing AC voltage directly which is output of this transformer. So we are providing the AC voltage input to this DB107 is a full wave bridge rectifier. So after this we will get a pulsating DC, and that pulsating DC of 12 volts will give an input to this transistor base through this potential divider circuit, and also trigger resistor is 1 kilo ohm. And after this the pulses will be given to the transistor, and transistor will getting switched on whenever the zero crosses the positive waveform, and then it will inform to the microcontroller through this three wires, and the microcontroller came to know that whenever the zero crosses, and based on the temperature it will set the on time and off time from the this BT136 transistor, and continuously we are going to send the temperature value through the Wi-Fi to the Blynk app, as well as we are displaying the temperature value on and speed level on this 16:2 LCD display. And on this motherboard there will be a reset switch just in order to restart the microcontroller, and this steel plated one is a crystal oscillator in order to provide clock pulse to the microcontroller. So from the clock pulse only the microcontroller will execute the instruction set which was coded inside the microcontroller. So let us go with the demonstration. Before switching on this kit we need to do some initial steps, that is we need to install a Blynk application in your phone. As I'm taking the video from my phone itself, but I will show you the output screenshots which is already taken before taking the video, and that was sent to the Gmail. And install the Blynk application in your phone, and then after enable the hotspot with the SSID of project 47HH without any space, without any capital letter. I'm repeating that, PROJECT 47HH, and the password is 1234567889, and then open the Blynk app. Okay, and then switch on the kit. As I have already shown how the Blynk app appears. So just I'm due to the availability of this mobile phone, I'm going to display the output screenshot directly. So you can see the welcome message on the LCD screen, and also the temperature will be continuously monitored and displayed on the LCD, right? And whenever the temperature is above 30 degrees, then level 1 will start, and above 40 level 2, 50 level 3, 60 level 4, 70 level 5. Like this, totally 6 levels will be controlled the speed for the AC fan. So let us see that by increasing the temperature, right? So now it's level 1, the motor getting start rotating. We can see the current is not sufficient for the motor, so that is right. This is the level 1, and next is the level 2. Level 3, level 4, and level 5 is the maximum. Now the fan is rotating with high speed, and at the same time the temperature decreases, level also decreased in the same manner, and also we are going to send the temperature values and levels to the Blynk app directly. So coming to the Blynk app screenshots, right? So these are the screenshots we have captured before starting the video. So for temperature above 70, there is a level 5, we can see that, and level 1 above 30 degrees, and level 0 above 20, nothing but below 30, and above 50 level 2. So these are the screens from the Blynk application. Right, thank you.